everybody. You are listening to the Medea podcast series. Medea Medical Education Academy is a global medical education provider dedicated to designing, delivering, and evaluating medical education programs worldwide. Today, we are going to speak with Justin Davies, Professor of Pediatric Endocrinology at the University of Southampton, UK. At the end of the podcast, learners should be able to understand, differentiate, and describe imprinting disorders, be aware of the underlying genetic mechanisms resulting in these disorders, and summarize the diagnosis and management of imprinting disorders. This podcast, Imprinting Disorders, a clinical guide, is part of the continuing medical education program entitled Growth Disorders 2025, Current Challenges, Solutions and Recommendations, targeting clinicians, particularly pediatricians, working in growth disorder management and those in general practice. Some content may be of interest to specialist growth disorder nurses. All materials will be suitable for all geographic regions.
My name's Professor Justin Davies. I'm a pediatric endocrinologist based at the Regional Centre for Pediatric Endocrinology at Southampton Children's Hospital, and I'm affiliated to the University of Southampton Faculty of Medicine. I have a research interest into imprinting disorders and bone metabolism, and I'm part of the Southampton Imprinting Group.
Can you please explain what an imprinting disorder is?
Imprinting disorders are a group of congenital disorders caused by altered expressions of imprinted genes whose expression is normally restricted by their parent of origin. So there are a few examples of these conditions that we see in pediatric endocrinology. For example, Silver-Russell syndrome, Beckwith-Wiedemann syndrome, pseudohypoparathyroidism, and much rarer conditions such as transient neonatal diabetes mellitus and Temple syndrome. And in total, there are 13 imprinting disorders. So how do they occur? Well, across the genome, there are imprinted regions where there are parent of origin restricted gene expression, and this is regulated by an imprinted center that acquires differential epigenetic marking, or methylation is the one that we most understand, in the egg and sperm. And after fertilization, the differential epigenetic markings, or methylation marks, become permanent at sites we call differential methylated regions, or DMRs. There are numerous imprinted loci across the human genome. Some are single genes, while others are clusters of genes whose expression is dependent on the parent of origin. So even though imprinting disorders are distinct from one another and they have clinical features that make them recognizable, they can also have overlapping features which particularly influence growth, for example. So many of these conditions will lead to babies being born small for gestational age, postnatal growth failure, or short stature. These conditions can interfere with the tempo of puberty and, for example, lead to precocious puberty. They can affect metabolism in a profound way, predisposing to obesity, type 2 diabetes, hypertension, and dyslipidemia. And they can affect development and behavior, in particular behaviors around food. And this might be a significant reduction in nutritional intake or excessive nutritional intake or hyperphagia. So what this means is that early diagnosis of imprinting disorders is important so that the correct management strategy can be implemented to optimize the outcome. The imprinting disorders are caused by 4 different mechanisms. The first are single nucleotide variations within the differential methylated region, copy number variants leading to duplications or deletions, uniparental disomy, or epimutations leading to loss or gain of methylation. And all of these causes result in changed expression of imprinted genes in humans, resulting in either increased or decreased gene expression, causing the various imprinting disorders. So SMVs, CMVs, and uniparental disomy are part of the spectrum of naturally occurring mutations, but the mechanism behind epimutations still is unclear, but we know that it can include factors such as use of assisted reproductive techniques or exposure to endocrine disrupting chemicals. And there are also genetic factors that can lead to imprinting conditions, such as maternal effect genes that are involved in the establishment or maintenance and erasure of imprinting markers. So to summarize, imprinting disorders, they share 4 causal mechanisms. They have overlapping phenotypes and distinct phenotypes. They cause profound effects on growth, metabolism, behavior, and neurocognition. And it's the early recognition and diagnosis of these conditions which is crucial to be able to institute the correct management.
How common are imprinting disorders?
So this is a good question and at the same time difficult to answer. There have been very few studies that have assessed the prevalence of all 13 imprinting disorders at the population level or in a single country, for example. And making assessment of the prevalence of imprinting disorders is difficult because of the variable molecular etiology. The molecular techniques have constantly improved over time. They're even better now than they were 5 years ago. And also the awareness of clinicians making a diagnosis of imprinting disorders is improving. And there are limited studies to date that have assessed the prevalence of more than one imprinting disorder. So, for example, Silver-Russell syndrome with Beckwith-Wiedemann. Probably the best study that can answer this question has come from Estonia. Estonia has a population of 1.3 million and has excellent demographic and genetic data that's available to researchers. The size of the country, together with a nationalized healthcare system, make it possible to undertake epidemiological studies of genetic conditions, covering a whole population, and in this instance, being able to detect the maximum number of imprinting disorders in a nation. The research group from Estonia investigated the nationwide prevalence of the most common imprinted disorders from 1998 to 2016. And what they found was that Prader-Willi syndrome represented about a third of cases, about 31% of cases. Silver-Russell syndrome and Angelman syndrome represented 17% each. Beckwith-Wiedemann, 14% of cases, and pseudohypoparathyroidism for 11%. And the remaining rarer imprinting disorders, such as Temple syndrome or transient neonatal diabetes mellitus, were much less frequently observed. But what this gave was a prevalence of Prader-Willi syndrome of 1 in 13,500, for Silver-Russell syndrome, 1 in 15,000, for Beckwith-Wiedemann syndrome, 1 in 21,000, and for pseudohypoparathyroidism, 1 in 27,000. And generally, we expected, and the researchers observed, that the prevalence was increasing over time. What these figures gave was a total prevalence of 5.8 per 100,000 of imprinting disorders, which was much higher than we'd expected. So although separately these conditions are extremely rare, taken together they are relatively common. And it's possible that the prevalence will further increase with better recognition by clinicians and improved availability of molecular diagnostic techniques. So this is an important point about the prevalence, given the profound effect of these conditions that they can have on long-term cardiovascular morbidity. And early diagnosis of imprinting disorders gives the opportunity for early intervention and prevention of associated comorbidities.
Is there any link between recurrent miscarriage and imprinting disorders?
Yes, there can be a link, and this introduces a subgroup of patients with imprinting disorders that have DNA methylation not at just one loci, but at multiple imprinted loci. And this is a condition referred to multi-locus imprinting disturbance, abbreviated to MLID. MLID can be linked to recurrent miscarriages. So first, what I'd like to do is give a little bit of background to MLID and then answer the question about miscarriages. So MLID is recognized in most, but not all, of imprinting disorders. So for example, in 12% of people with Beckwith-Wiedemann syndrome, they will have MLID. 5% of people with Silver-Russell syndrome will have EMLID, and 60% of people with pseudohypoparathyroidism type 1b will have EMLID. But this is still not fully established because it's only very recently that laboratories have been offering the ability to investigate for the possibility of EMLID. Clinically, EMLID is heterogeneous. People with EMLID may have blended features depending on the imprinted loci that has been affected. EMLID is usually seen in patients with loss of methylation at a given clinically relevant imprinted region, and only very rarely in those patients with SMVs, CMVs, or uniparental disomy. So what this means is that some patients with EMLID will have a very obvious phenotype of, for example, Silver-Russell syndrome, even though they have changes in multiple different methylated regions. But other patients can have a molecular diagnosis of both Silver-Russell syndrome and Temple syndrome. Other patients may have a diagnosis of Temple syndrome and at the same time Beckwith-Wiedemann syndrome. And you can even have people with 3 diagnoses, such as Temple syndrome, Silver-Russell syndrome, and Beckwith-Wiedemann syndrome. And the phenotype of these people may be expressed as features of each of the conditions, which means that the management of these people with EMLID can be very challenging because it needs to be tailored. And sometimes the management strategy for each of these conditions can conflict. It's worth reflecting on what's happening here. These are not contiguous gene defects where a deletion in one area of the genome affects or causes different conditions. What is happening here is that distinct and different areas of the human genome are affected simultaneously. So in the case of an individual with EMLID who has Silver-Russell syndrome and Temple syndrome, it means that the genome is affected both on chromosome 11 and chromosome 14 at the same time. So how does EMLID arise? What causes EMLID? Well, we know it's more frequent in those requiring or accessing assisted reproductive technologies, and it's probably more frequent in those exposed to endocrine disrupting chemicals. But there are also some genetic causes that can cause EMLID, and some of these have relevance to recurrent miscarriages. And I want to introduce here something called the subcortical maternal complex. So the subcortical maternal complex is a multi-protein complex that is expressed just below the oocyte membrane and in pre-implantation embryos. And it's essential and it's needed for zygote progression beyond the first embryonic divisions. And it's also essential for the establishment and maintenance of imprinting marks, including methylation. So disruptions of the genes that code for the proteins in the subcortical maternal complex, and the examples that we know about are PADI6 and NLRP7, disruptions in those genes can interfere with the function of the subcortical maternal complex and can lead to the zygote not progressing and therefore recurrent miscarriages, or in rare instances where the zygote is able to progress, there can be profound disturbances in the methylation marks leading to EMLID. So to summarize, there is this link between EMLID and recurrent miscarriages, and this is important because what it's done is it's given us insight into one of the mechanisms leading to imprinting disorders.
What take-home messages do we have at the end of this podcast?
So the take-home messages are that imprinting disorders are often overlooked and there's a delayed diagnosis. Early diagnosis is essential for the institution of bespoke management for each of these conditions because the management is different for each condition. We know that these conditions generally can have associations with long-term cardiovascular morbidity. So making a diagnosis is crucial for the early institution of advice regarding a healthy lifestyle and for monitoring for cardiovascular morbidity so that treatment can be offered early.
Thank you for listening to this Medea podcast. For more information about our continuing medical education programs, please visit our website at medeaacademy.com.